So let's now learn about correlation and linear regression. So let's look over to my data that I prepare on my computer screen here with Microsoft Excel. And for now, before we begin to and get too far here, I'm going to highlight this area right here, and you can please go ahead and pause the video and have a copy and note down the data here. You don't need to worry about anything outside of the highlighted area. Everything we need in the data is here. So the idea now is that a lot of time we are working with two sets of data. They have, so the column in my X column right here, you can think of that as one type of data. One data represents some meaning, some measurements. The other column right here is a different set of data. And so once again, keep in mind that these are two completely different data. And keep in mind here that this data, once we have recorded them, then they have to stay in this particular order as a pair. So I have my choice to and anyone have your choice to rearrange one of the data into a certain order. However, the other data have to follow along as existing as a coordinate pair here. So for example, once 0.45 in a y value is being recorded together with 5 here, they exist as a pair of values. So 5 here in this data, 5 is a pair of value is being paired up with 0.45, and then 10 is being paired up with 0.68, and etc. and etc. When we're looking at that data right here, and keeping in mind now, understanding that we don't need them to have a functional relationship or anything like that. And I repeat, we at start right here, we really don't need them to have any kind of a functional relationship here. All we understand is that these are two completely independent data. But since they are paired up, we can start taking that nature of that the data here exists in pair here. We can put up a way to graphically display them. And so let me quickly turn over to the graphs here. And so we can now put them on the graph as scatter points. So this plot I brought up right here is called a scatter plot. And just as the name is indicating, this plot right here is not intended, it's not meant for, we're not going to look for, is there a curve, a zigzagging curve, or some kind of bent curve, or whatever that go through and contains all these points. That's not the point we're looking for here in a scatter plot. And as the way how the name of this plot is indicating, we simply treat them as plot that shows scatter point. So each one of our points there. So quickly back on my writing board. So you have a scatter plot, and all these points here being plotted. And so each of these points is being referred to as a scatter point. And so all of these are scatter points. And back to my screen here on the computer, and you can see that each of these points, or if I can quickly show the label here, that point here is showing at 5, 0.45. So each of these points are actually directly from our data. Each point exists as a pair of data. So say that point here is that pair of data, 6 for x and 0.62 for y. And then that point here, for example, being 9, and you can see that there's a little label that pops out right there. But this point here is 9, 0.78, and so on and so on. So once again, all we need to look at here is this plot is it's simply a scatter plot that contains scatter points right here. And once again, I highlight the understanding that for now we do not look for, we don't need to worry about, is there a functional curve, is there a functional relationship existing between these points. They are not meant to be related. They are just simply two separate data that we collect and record it. even though I keep saying that we don't need to worry about these two data having a functional relationship between them, but so here's the thinking process. Completely looking from scratch right after the moment we recorded them, we have no clue whether or not these two data are related or having any kind of pattern exists between them. And that's the whole idea. We became curious and we want to know. So at first start, we don't know if they have any relationship, and we're gonna start looking for that. And so for that reason, we want to find out if the two data here have any kind of correlation. And so correlation here, in the way how we see, it's just any kind of pattern. Any pattern existing between the two data. So I'm not exactly giving a formal definition of what a correlation is, but I'm just pointing out that when we get into doing the correlation work, these are the kind of concern we're looking at. We want to know, is there any pattern existing between the two data, or can one data value, say it could be X or Y, be dependent on the other one. And so that's what we're looking for. And so to start answering our concerns, our curiosities about the data here in terms of looking for a possible pattern existing between the two, or can we treat one variable, either the y or the x, being the dependent variable on the other variable. And so let's look over to the scatter plot that I have prepared for this data. And keep in mind that there are tons of software and programs out there in the market in these days that can handle the scatter plot for you, that can create nice looking scatter plot. Even a TI calculator, a 84 or 83 version, can put up a scatter plot like this. So nobody in these days really have to do these scatter plot by hand anymore. They're not accurate, and it's pointless of doing that. What's more important is we understand what a scatter plot can tell you and what a scatter plot can do for you. But so here's the scatter plot right out from that data again. And so, as already been said, for now we can't really tell if we should even put a curve up and down to contain all these points. And so that's not the main goal for now. But at least if you're looking at the entire regions here, so you have a scatter plot and think about just circle. Don't need to worry about how precise that region is, but you can see my mouse movement right here is trying to circle a region where we recognize there are scatter points here. Or in other words, let's turn over to my writing board here, and let's pretend that we have a scatter plot, a few scatter points here. So with a lot of points like that, then I am not really looking for that up and down curve between all these points and connects them. Nope, we're not doing that. So what I'm looking at is the entire region. And sometimes we use the term scatter region. So this scatter region is starting to tell a certain pattern about the data right here. So this scatter region is similar to the one that we have on my computer screen right here. And so here's the thing. The scatter region we see in this data on this computer screen seems to form a rising trend. And that's all I'm saying. The region itself seems to be rising. And by the way, I gotta clarify that rising or falling in the mathematical understanding. It just means from the left to the right, does it seem to get higher from the left to the right? And it's been famously known that anytime we're looking at a graph, then we always look from the left to the right because values go low to high from the left to the right. And so once again, as we're looking at this scatter region from the left to the right, the entire region does seem to rise. Even though if you look detail into each of the points here, then some points rise from the other point and drop, some other point drop from the other point. And so we have a lot of up and down among the points. But like I said again, that's not the point. The point we're looking at is the entire region of points right here, of scatter points. Those that seem to form into a rising or falling. So now let me take aside a little bit here into my writing board. So let me start making a couple of descriptions here. But so as I was starting to talk about the regions of scatter point and are they rising or are they falling? And right now, like I said again, we are completely depending on our own the eyes to look at it, and our own visual sense can tell us. So when scatter region form into a region like this, so from the left to the right, the region seems to be getting higher from the left to the right. So a region like this, yes, making a note of that, is a rising trend. Or I say it's a trend, because we still don't know exactly what the pattern is, but we can see that it's forming into a rising trend. And so we can now start using a couple of terms here now, that recognizing a rising trend in the scatter region, now we can start saying that this scatter plot here, or the data being represented by this scatter plot, is having a positive correlation. It does. So basically, we still don't know what exactly that pattern is, but we can now say that it has some kind of pattern and going positive. And so similarly, there are other times when you're looking at a scatter region of a scatter plot, and all the scatter points, a lot of them, and after considering the entire region here, it could be fat, it could be thin, but it does seem to form into a falling trend. That's simply what we notice through the eyes. And so a situation like this, when you recognize that in your correlation scatter plot there, then we're going to refer to this as that situation that is being a negative. We're having a negative correlation in the scatter plot, or we're having a negative correlation in the data. And of course, we put the y data on the vertical axis, the x data in the horizontal axis. And so back into my screen that I prepared with Microsoft Excel here, then this region here, completely disregarding all of that up and downs among the points, but the entire region of the points here does seem to form into a rising region. So what we can see here is that now I can use that new term we just learned here. The data is being, the data is having a positive correlation, some kind of correlation, some kind of pattern going on, but for now we know that it has to be a positive correlation. All right, and what I'll do now with this data is to put up a line. And like I said, for now we don't need to worry about having a functional relationship here. And about this line, it will come to the point where we will learn how to find that. But for now, just Microsoft Excel have put it here, and this line is to indicate that at least all our scatter points bouncing up and down from that where that line is, but together with the line, it seems like all these points are bouncing around that line, and this line, consistent with what we concluded earlier, the data we have here is having a positive correlation. And so you can see that the line here is having a rising slope right here, and of course, anytime we're looking at a line and we have a slope, but I'm not talking about the algebraic slope right here. It's just simply the line here is indicating a rising trend, so it's being consistent with what we concluded earlier about the data as being a positive correlation. And so that's all it needs right now. We will come to learn how to find the equation of that line for the exact calculation. But so here, once again, check it out. Some points are still being far away, and some points pretty close to the data, and some other points are far away, and together the whole regions scatter around that line right here. And so now I'm going to go back to the data, and let's put up a scenario right here. In your data, a lot of time when we collect and record the data ourselves, there could be errors. So let's say I'm going to pretend that, hey, we recognize that in the Y data right here, we made an error that 0.53 should have been 0.65, and 0.78 should have been 0.7. So I'm going to make updates to two entries right there in my Y column. And I'm just writing these here, so later I can go back to my original lecture. But so the data now is updated for new value. And so let me show you. So basically we're going to expect a new scatter plot. So I hope you can at some point rewind the video here and look at the scatter plot before I updated this data. And now here I'm going to bring up the updated scatter plot for this data here, this updated data. Now the new data is here, and there was a little motions about how the point jumped a little bit, and the line is still there. I mean, it doesn't even have to be the same line, but there's still a line. Any data, any scatter plot has some kind of line, and later we will learn what that line is. It's not the function that contains all these points, but it's some line that later on we will learn. But now you can see that all these points once again are still being around, bouncing up and down around that line right there. But now, what's different with the earlier scatter plot? The points here now are a lot closer. They are a lot more closely lined up on this line right here. And so, let me get back into my writing board here, and that actually describes the situation so far. So we're still looking at a positive correlation, a rising trend. And even if after I updated my data on the Microsoft Excel screen like that, the scatter plot was still a rising trend. But what we notice now in a further situation is that the points are more closely lined up. So the bandwidth here, the entire regions of points, the entire scatter region became a lot thinner because the points are more recognized to be lined up into a line, some kind of line. And so it's still a rising trend, but and still having a positive correlation, but seems to have a much thinner bandwidth. And so the situation like this, we refer to that as having a strongly positive. It's still being positive, but a lot more recognizable, a lot more closely lined up. So we refer to that as strongly positive correlation. And so if you're putting up a question, if we're having a question for ourselves that, so how strongly, I mean, how thin is thin enough to be considered as strongly positive correlation? And that's actually, in my experience of doing statistics work right here, that's not really the main point here. The main point is it's being strongly compared to some other version of the data, which is more widely spread out. So these are two different versions of positive correlations, but the data that's positive correlation and being more lined up, more closely lined up compared to another data is referred to as strongly positive correlation. And so similarly, having a negative correlation, and we have a bandwidth that seems to be creating a falling trend right here. And then so in some other time we have similar data, or we make some correction to update the data, and we recognize that the data scatter points become still a falling trend, a negative correlation, but a lot more, and I intend to draw something that's a lot more narrow, a lot narrower, and a lot more lined up right here. So something like this is being referred to as a, and we have seen that the term, so we can now make a good wild guess here, but the term for this now is being a strongly negative correlation. And so now we've been talking about how a scatter plot can have a rising trend, and there we call that as a positive correlation, or even a closely lined up rising trend, and we call that in the formal term is a positive, the strongly positive correlation. And then versus in some other case, our scatter plot turned out to be a negative trend. Then we refer to that as a negative correlation, or sometimes a closely lined up, more closely lined up version of those data. We refer to them as a positive, as a strongly negative correlation. But then so we need to come up with a way to precisely communicate about how strongly or how positive a correlation is, or how negative a correlation is, or even as well as how strongly positive or how strongly negative. And so we come up with a calculation value here that we call the correlation coefficient. So a correlation coefficient is a value we can calculate right out from the data. So for now, to start out, let's just do it's a value. It's the value we can calculate to indicate how positive or how negative or how strongly positive or negative the correlation can be. And so that's the whole purpose of coming up with this correlation coefficient. It's every data has a unique correlation coefficient. Every pairwise data, as we're studying here, has a unique correlation coefficient. And then we use a lowercase letter r here to be the symbol for correlation coefficient. So it's just the symbol for the calculation for the math that comes later. And so as soon as I introduce the purpose of having a correlation coefficient, then before we can get into some real calculation for the correlation coefficient of any data set, any pairwise data set, correlation coefficient is famously known to be anytime you finish doing the calculation, the value is only anywhere from -1 to 1. You will never have a correlation coefficient value that falls outside of that interval, meaning the correlation coefficient being greater than 1, greater than a +1, it's never going to happen. Correlation coefficient being less than -1, it's never going to happen as well. So anytime we finish calculating a correlation coefficient, and if we recognize a value that falls outside of that interval, we need to go back and correct our calculation because it's just simply wrong. It's just the way how it is. And still, a little bit more before I showed the calculation for the correlation coefficient. But let's bring our brief understanding of the correlation coefficient right now into the data, into any scatter plot, and see how correlation coefficient connects with the scatter plot here. And so, first of all, keeping in mind that correlation coefficient is anywhere from -1 to 1. And this interval has some area of that interval being a negative value of r, and there's some area being positive value of r. It's just simply the value has to be anywhere from -1 to 1. And so when your scatter plot is a rising trend, or we already seen that term, this is considered as a positive. This data has a positive correlation. Then now bringing in the understanding about the R coefficient, the correlation coefficient. We haven't learned how to calculate that, but for a data like this, where it created a positive correlation, value for R has to be a positive value. I mean, it makes sense. Positive correlation, and R is the coefficient to measure correlation, and so being positive correlation, R is positive. And so similarly, when you're having a data that clearly through the eyes at looking at it, you have still positive correlation, but the bandwidth now, the scattered region is a lot thinner, or in other words, the scatter points are more closely lined up. We introduced the term strongly positive correlation, but how is that being explained with the R value? So R is still positive, of course, but now further we say that R in this situation here where we recognize strongly positive correlation, then the R is closer to positive 1. All right, so think about what makes sense here a little bit. The -1 is the low extreme, positive 1 is the high extreme. So here's the interval between anywhere from -1 to 1. So, and 0 is exactly in the middle. So if R stays somewhere to the right-hand side, that's a positive. This is a positive area for R value. So if R stays somewhere inside of that positive zone here of the values, then we're looking at these either some positive correlation or even strongly positive correlation. But then, as R keeps getting closer and closer and closer to that extreme end being a positive 1 right here, then the bandwidth became thinner and thinner, more strongly and more strongly positive. And so I underline that term closer right here because I keep having students asking me, so how close is good enough to be close to positive 1, to have a strongly positive correlation? But so the point I really make it clear now is that the closer R is to 1, the more strongly positive your correlation is. And then in the different situations, your scattered regions can form into a falling trend. The regions seem to be falling down from the left to the right. And so formal term, we refer to this case as having a negative correlation. And having a negative correlation, the R here, so once again keep in mind, rule of thumb is always R value after calculation have to always turn out being a value anywhere in between this interval here, or the least is -1 or the largest is positive 1. So having a negative correlation, then it makes sense that it should connect with our correlation coefficient value in a sense that the value there has to be negative. It says in the data like this. We say out through the term that it's negative correlation. So calculation should show that your value for R is being less than 0. And then, likewise, there will be time where in your scatter plot, we're having a negative correlation again. However, here we recognize the bandwidth is a lot thinner. And so the term we used for this was strongly negative correlation. And so, and of course, here we well understand that the R should be negative value. But now, a further understanding now is that since the bandwidth here is small, and we're looking at what we so-called at strongly negative correlation, then here I can see that R should be, or R needs to be closer, again, closer to -1. Right? And so once again, I'm going to bring up that similar interval. So you got an interval, 0 is exactly in the middle, -1 is here, 1 is here. So if your R value comes out after calculation being in the negative zone right here, somewhere to the left-hand side of 0, that's some negative correlation. But then if you keep getting closer to the -1 extreme, then we're having a, so these are referred to as what we call strongly positive. They just keep getting, strongly negative as we keep getting to the closer to the -1 extreme like that. And so likewise again, for those students who keep asking me about how close is good enough for being strongly negative, then it's just the closer to -1 your value of R is, the more strongly negative your correlation is.